All right, so here's an example that uses what we've talked about as well as this new rule. First thing I gotta do is distribute. So I gotta get this 5 spread over everybody.
Does that mean A5?
So it's gonna be A to the 5th.
Wait, why is this spread?
B to the what? 20th. Somebody's gonna write 9th. Yeah, remember when it's power to a power, we multiply. C to the what?
10th.
C to the 10th, and then B to the...
5th.
Okay.
And then you add the 2 B's.
Well, they're divided, so I subtract them. So it becomes A to the 5th, B to the 15th, over C to the 10th.
How would you write it on top? So easy.
Well, part of the reason it ends up on the top,
Because the top is bigger.
because the top is the bigger. If I do 20 minus 5, I get 15. If the bigger number is on the bottom, then I could just leave it on the bottom and subtract them.
What if it's like 5 and then negative 20?
That would be subtracting a negative, so you'd be adding.
But 5 isn't bigger than 10, so why is that so?
Because it's supposed.
Because they're different bases, A and C. I don't combine this 5 and this 10. You only you only combine the ones with the same base, which are the B's. I can't combine the A and the C because they're different bases. Yeah, sure. The other rule of thumb you guys can fall on is just subtract the top from the bottom, so 20 from the 5, and then deal with shifting up and down. Let me show you what I mean by that. Go. Yep. Let's do P to the 3rd, Q to the 5th, over Q to the 6th, the whole thing squared. And again, I want to keep giving you guys lots of rules to think about, lots of opportunities to practice these earlier ideas. And then let me use this also as a way of illustrating kind of, I think, the easiest way to approach the subtraction. They're making ice cream over in chemistry. That's the shickety sound. They're shaking stuff with ice. I think they're making ice cream.
They are.
Okay. It's a chemistry thing.
Must be gross. Ice cream. You made ice cream last year.
You put enough sugar in it. So, guys,
Can I do it?
what do you want to do first? Let's get through the first step, Janelle.
P to the
Taylor,
Yes.
what?
P to the 6,
P to the 6th,
Q to the 10,
Q to the 10th,
over Q to the 12.
over Q to the 12th. Awesome.
Then you have to subtract 10, so you get Q to the 6 over Q to the 2nd.
Okay, I'm going to write this down before we get to that step. Now, you sound like you got it, so you might want to tune me up for a moment.
Negative.
10 minus 12 is
Negative 2.
-2. Now, I know with negatives, those have to go in the denominator. They have to switch places. So that's kind of like the safest way to not screw up with the sign when you do the divisions, is to follow the rule of, I got this by going 10 minus 12. That gave me a -2, and therefore I moved it to the denominator. Now, if you can cut right to the chase, bigger numbers down here on the bottom, so I'm going to go ahead and do 12 minus 10 leaves me 2. That works too. Whichever way works best for you. What's up?
Alright. So you probably said this a lot, but
Yeah.
when there's a negative at the top
Yeah.
and you put it to the bottom, why is it a positive?
The process of moving it from one to the other is dealing with that negative. So when I go from x to -2 and I move it to the denominator, when I take the reciprocal, that's what that negative is telling me to do.
So it's just
Once I've done that direction, I don't need to worry about doing that direction again. What else can I say about this particular problem? It's the last rule we have to talk about. So if we get this, we're in good shape. Okay, let's mix it up with one that's really kind of a grab bag of everything we've done so far then. Let's take 2/3 squared and 6m, yep, over 2n to the -3rd. Let's knock that guy out of here. All right, let's see.
How you doing?
What do you want to do? What do you want me to write? Let's get the first step done.
Wait, are you gonna multiply the 2 or are you gonna square it?
Let's deal with the exponents first. Since they're in parentheses, I should deal with clearing out these parentheses first.
Alright, it's 4, 6.
Wait, why 4?
2 times 2 is 4.
So it's 2 squared?
Yeah.
Okay, so 2 squared over 3 squared.
Well, do we have to write that
Wait,
stuff out?
why didn't you?
Yeah.
Wait, why didn't you?
No,
just-
like, do we
Why
actually
can't you just
have
write,
to,
4 over
or it's
6?
just...
Oh, okay. The reason you don't want to write 4 over 6 is it's not 4 over 6, it's 4 over 9. That's the big reason. Is that it saves you from making a small mistake just by rushing through the problem.
So whenever
If you-
there's a fraction and there's no variable, you just put it like that.
Yeah. Plus, with these negative exponent, this negative exponent, I want to be sure before I start mashing stuff together that everybody's in the right place.
Oh, like your negative?
Yeah. Like I don't want to rush right in to combining things because I want to make sure I deal with all of these negatives appropriately. So let's kind of keep rolling here. I'm going to keep these. I'm not going to change. Evaluate. Let's deal with these negatives before I try to evaluate.
The negative on the bottom?
So 2 squared. This is going to go to the bottom, right? So 6 to the third. M to the third. 3 squared. This is going to go up top. 2 to the third. N to the third, right?
Why that one go on the bottom?
thought that was an H.
That's an N.
No, I meant like over there.
That's an N, yeah. Now again, take a look at what happened from here to here. All I did was take the 6, the M, the 2, and the N, and switch their positions top and bottom. Because that's what the negatives mean. And like I've said before, you want to be really careful with these negative exponents to make sure everybody gets in the right spot.
Wait, why did you put the M before the 3? Where did you put the 3 squared from?
3 squared is this 3 squared right here.
Why did you put it in that order?
Oh, as I'm working, I'm just going down my line on top, and then not really yet, no. No, it doesn't really matter until I get to my final answer. Now, to streamline, what's 2 squared times 2 to the third?
2, 4 goes 2.
4 times 8.
2 to the fifth, right?
2 to the fifth.
Okay. N to the third. Yep. 6 to the third, 3 squared. Now, I really can't get any neater than that, so I'm just going to have to multiply everybody out and call it a day. 2 to the fifth, that's 2, 4, 8, 16, 32. I'm multiplying these out now. So 2 to the fifth is 32. 6 times 6 is 36, times 6 more gives me 216, times 9. 2 to the fifth is 32. 6 to the third is 216. 3 squared is 9. Final answer, 32 n to the third divided by 216 times 9, 1944 m to the third.
Why did you multiply the 216 and 9?
Because it says multiply.
Wait, how'd you get 216?
Where does it say multiply?
If there's no operation, it's implied multiplication.
Wait, how'd you get 216?
So that's one of the rules of algebra. If you're not sure, I mean, this whole all through here, it would help. You can go in and put the multiply dots. Yeah, see, they get kind of intense as we go through these. The rules themselves, it's kind of like Othello, the game. It doesn't take long to learn the rules, it takes a long time to get good at it. Moments to learn, lifetime to master.
Yeah. Next problem.
Next problem? Yeah, they got it. Shut up. All right.